Hi everybody, it's Mrs. Cassell. I got some requests to get some help on the cruise control lesson in CoderZ. This is in the Cyber Robotics 102 course, so I thought I'd take a crack at it and we'll see how far we get. There's a couple lessons that go through here, and so these you can watch. I'm going to sort of blink through these right now just so I know what we're doing. Alright, we're talking about using the set power block. Ooh, I love this because we're calculating what the speed is. Um, yeah, I have found that speed is this is super cute. The speed is very powerful in your robot control. So, oh yeah. Oh, I've done this one before. I wish I had a recording of this already. Okay. So yeah, I know how to do this. Oh, my webcam is totally in the way of me clicking this up. So sorry, I'm going to move on. Okay, so speed limit. So the whole idea here is that you're going to have these moving objects, and you just want to find the sweet spot for the speed of your robot. So we're used to setting our power at 100 and then, just sort of seeing what happens. And that's not going to work this time. So I found this is true with the Python gym as well, and it happens in real life. Everybody wants to make their robot drive at 100%, and then kids are surprised when they can't make turns accurately, or they'll run a maze in class with their Lego robot, and they'll get it right one time, go back, add the next part of their program, and then be really surprised. So, yeah, I'll turn on my HUD. Use a manual control. Okay, so this first one, down here, there's this little blue plus button, plus button, and there's this thing that with a video game controller, I find it super hard to use because you use your little keyboard. So I'm going to go ahead and run the simulation here so that it gets started. Oh, is it not going to go? Oh, did I break it? Come on. Come on. Oh. Do I still have to use it? I thought I could just do the manual control here for this. So let's go ahead and reset right there for a second. Is that not? Go to manual control. Activated. Yeah, that's what I thought. See with the manual control, not only do I have to steer and this super annoying camera angle activity. So, there is a button in the lower. I just want to do this again so I can show you. I find this little button really useful, especially when I'm being analytical. It's so far away on a lot of them, but I think it obeys the I don't have a real mouse with me. Yeah, it obeys the control scroll zoom functionality, and you can I don't know that you can move it. If any of the rest of you figure out how to move the camera, that's fine. So this is a pretty good camera view for me though, so I can make this work. So I'm gonna go ahead and turn on that manual again. I like this too because it's a better angle for what I got. So I can just see. Oh, my bad. Oh, got carried away. Oh, like this. So blah blah. Okay, there I made it. Okay. So that made driving it easier because it was actually driving forward, which probably was on the other one, and I misinterpreted that for them. So now I'm guessing that they're going to teach me how to control that with my code instead. However, it's going to take 1 billion hours for my computer to load that. So in the meantime, I'm just going to get to sort of look at this little spinny thing. Ooh, wow, that's like hardcore stuck right there. Come on, computer. My computer's super hot because, as it happens when you do all your work late at night, you're like snuggled in your, flannel pants with a blanket, and your computer goes, please do not press that against my heat sink and my fan input and output. All right, I'm going to close that and try that again real quick. Much better. Okay. Cruise control. So we're going to try to set that up. We're going to set, we use predefined power and predefined time. 2 types of system control, an open loop, which is excellent. So or operates without processing any feedback from outer sources and does not change its behavior according to its environment. So, the example of a toaster, great example, right? So toast catches fire in there, it doesn't change what it's doing, right? Closed loop is a control system that takes into consideration feedback from inputs it receives and operates according to that data. So how would you turn each of the open loop systems from the previous slides into closed loop systems? I should put that on a quiz for you guys. It's a great question. So which of these do we need to build in CoderZ in order to drive forward? I'm gonna go with closed loop because I need to like know how close I am or be able to measure my speed and then change my behavior accordingly. So I need some input and then need to make a decision based on that. Oh, I got it right. Okay. So we're going to think through our pseudocode. So step 1, check the robot's speed is lower than the speed limit. If yes, it is lower than the speed limit, then we want to keep driving forward. If no, the robot speed is over the speed limit, then we need to slow down. We want to just sort of constantly do that until we reach our target. So now we start turning this into code. So we're going to look for this if then. So this is control flow. Over here, we're going to look for an if else. I guess it's not if then. If else statement. We can find the if block over here, and we'll expand this if block into an if slash else. So then if the block has a plus button, clicking it will add the else. All right, that's good to know. That's how you get the else in there. And then this obviously for my constraints that I'm going to put in there. The else block operates according to a single statement or condition. If the condition is met, yes, then the robot acts a certain way. If else the condition is not met, the robot acts in a different way. Yep, I want to be lower than the speed limit. Robot speed has to be less than, I went too fast, sorry, my bad. Let's go back. Robot speed has to be less than the speed limit. Okay. Sensor menu has get robot speed block. That's cool. Okay, so I'm going to say that, and then I want that to be less than or equal to my speed limit, and then I'm going to use, we'll set that there. Oops, right click and to click this. So what do we do for conditions met? I think I got this. So yeah, I want to drive forward, and then I want to brake if I'm over the speed limit, right? Okay, let's do it. We have our code with its condition and the appropriate response. Uh-oh. Let's go back to our pseudocode. We need to place this code inside of a loop. Oh, okay, yes. Okay, so they just showed me how to use the if-else statement, which checks for that sensor data and tells the robot what to do either way. But we need to make sure it's inside the loop so that it will do it over and over again. That makes less sense. So we're going to repeat. Make sure to place the existing code inside the repeat forever loop's arms. Okay, so that's why they taught this lesson in this order. I'm going to make that code first and then drop it inside the loop. I don't know if that's really essential or if that's just, the way they were doing things. Okie dokie. So, it's time with code. Well, they've already got it set up for me. I just need to make the loop and they've got it set up for 75. Okay, so she needs to be driving under 75 centimeters per second. And if she is, her brakes go to 100. Sorry, power goes to 100. If she's over the speed limit, she brakes. Okay. Yeah. All right. I'll take a look at that. Yep. Can I figure out what's left to add? I can, baby. I want to repeat this loop forever. Like that. Okay, I'm pretty sure that's going to do the thing. So, oops, sorry, scrolled crazy pants. Let's go ahead and run it and see what happens. That's pretty nice. Ooh, I love this flashing so you can see what part of your code is going. It's just super fast, so that totally works. I can't see my victory because it's off screen. Oh, there we go. Okay. All right, so it's good. Alright, now cruise control. Oh, last time it helped for me to reload this. Ruby needs to climb up a slope while still sandwiched between the bad containers. Ruby knows how to maintain steady speed. Okay, we just figured that out last time. This is where I often find that I'll get started and they'll give me a blank box and I forgot this. So I write this stuff down, or I would if I were you. We'll build our control loops, which include both of them. Do I remember how to build those? Yes, I do remember how to control those. Ruby's driving up a slope, then downhill, all while avoiding the bad containers. Here's what it should look like. Remember, downhill means Ruby will go faster. So should we still build our condition asking if the robot's speed is less than something? So our if-else loop will deal with going downhill first. So if our condition is set at if the speed is less than 100, in other words, if the robot speed is greater than 100, I can read, sorry. What should we do if we're going faster than 100? We should brake. Since the bad container is right in front, she needs to brake. Need a reminder of how to brake? No. I think so. It's the brake wheel set to both, right? Oh, yep, they're even showing it right there. Perfect. That's your code, just goes from the drop-down menu. For speed, that's uphill, so we can go at full speed to keep up with the bad containers. Okay. I think I got this. Okay. So let's go ahead. Uphill scuttle. Is that what this is called? Uphill scuttle. This time you need to build a condition by yourself. Ugh. Okay. And the math in there, and then get robot speed as a sensor. Power and values are different from the last mission. Rude. Okay, so I want to have this if else. That's my control flow. That's right there. I want to use this get robot speed if it's less than or equal to, and I need a data point. I want a number. Put in what? They had 100 in the little example. So, oh wait, this time we're saying if it's greater than, we want to break, right? No, if it's less than 100. Oh gosh, guys, it's late at night and I'm not paying enough attention. So let's go ahead and see what happens here. Do that. Oh, and I need to press the button to change it to an else. Otherwise, I'm going to break. Yeah, let's give it a try. I'm going to change my camera view and then use my control and scroll. I love this. I love how creative the world edges are. Like, they put effort into that. That's a great game design. Alright, let's go ahead and see how well I did. Let's see what happens. It's going to repeat forever. So it's going to drive forward. It's going to say, I need to go faster. Oh. Oh, Lord, that's frightening. Keep going, Ruby. Keep going. Oh, it's going to catch me. Will I get to my target first, though? So, I just want to take a look at this real quick. Think about, so I set my power there, um, and that makes sense. In the last map, they used get speed, and they were describing the speed as 75 meters per second. I don't actually know how fast this is. I assume the blocks were going the same speed, and I probably could have used a different bit of code right there. So, but hey, we got it done. All right, steady climbing. We're going to do 2 in a row here. Okay, so this one, ooh, we're going to climb up, and then we're going to climb down, it looks like. So, we're climbing up and we're climbing down. So it looks here. So this one, it doesn't give me any instructions. I have to read my code. Okay, so I'm going to be doing this loop forever. And I've got an if else statement in here. So if the robot speed is greater than 80, then we should brake. And if it's um, not greater than 80, then we're really going too slow. We should speed up. So juice those motors. All right, so that was the idea here. So I'm going to go ahead and run this and see what kind of progress we make. Uh, come on, Ruby. Okay, nice. That's painful. Switch this anytime I can. Okay. Sweet. Okay. Well, that's good. That was easy. But it's helpful to read that to see what those examples really are. All right. Cruise control. Manage several missions by building our own closed loop control block. That was tough. What if it could be much easier? I like that. The set speed block. You can set the speed you block and it will do its own cruise controlling. Excellent. So up next, curves and turns. Okay. Oh, well, that's all there is in this? Okay, so I've got just these two challenges that are left. Sweet. Okay, so this time we can use that get or set speed block and we'll have exactly the right speed. Now we can use the set wheel speed block to control speed. I'm always a little frustrated with these. Oh, I got my cable. Oh, no. Nobody throw up. All right. You find the set wheel speed block here in the movement category. Got it. Got it. I'm all over this. Okay, so from what I can tell, this should literally be this easy. But what we saw last time, actually going up a hill 100% seemed okay. So let's go ahead and try it and see if it's too fast. Oh, yeah, it is. Oh, oh, there she goes. Oh no. Oh no. Okay, well, we just gotta watch that happen. Where did Ruby go? Oh no, she's in the abyss, isn't she? We're just oh you guys. Oh, okay. Let's fix that. So, as we see, setting the wheel speed to 100 didn't work. It sure did work at 75, but I have no way of knowing if these blocks are going the same, because I don't actually know what our distances and times are here. So, it's really good. 75 too. I'm going to see how long it takes the big block to get to the top here. All right, it took 14 seconds for it to get to the top. Um, Oh, the blocks will just keep going. About 14. One of the things, I don't know if you guys remember, down here in this blue tools, there's a measure tool. So I'm going to measure from here to here, from the top, is about 11 meters. So it took me, let's just estimate 10. Well, I don't know why it matters. 11 meters in 14 seconds. I'm going to do that on a calculator because the time of day that this is makes mental math really arduous. All right, 1 point, or sorry, not 1.1, 11 divided by 14 is 0.78. So according to this, the block is going 78 centimeters per second. So that tells you just how accurately I measured things. That 75 was way too fast. So you can absolutely trial and error this thing. Like that's okay. Like I did there, the idea of measuring distance and time. Oops, I forgot to reset the simulation. The idea of measuring distance and time is really helpful. I sure don't feel like I'm slowing down at all. So makes me wonder what's happening here. Are these really that slow? Let's do something insane, like set it to 10. Well, that works, except I'm going to get crushed from behind. All right, no. Let's go ahead and do 20. So it is true. These are moving much slower. I've got negative 25 points on there. How funny would it be if that was an indicator of the score, or their speed, I mean. Ooh, this is looking pretty good. So cruise control in a car works in a very similar way, right? It uses sensor data to determine, how fast the car is actually moving, and then if it's going too slow, it puts the gas on. If it's going too fast, it brakes. So remember, the set wheel speed block is a very useful shortcut. All right, what am I trying to do? I guess I want to get up the hill and down the hill. I'm going to choose the set wheel speed. Let's go back and do what we were doing, which was just set this to 50. Clearly that's too fast. The blocks really get on the hill going up. Alright, this is the last challenge. Alright, I do feel like it'd be too easy for the same speed as last time, but oh no, that looks pretty like the real to end up being. Just in like higher speed? No. Camera work is simulation. Somebody needs to. You should always see your robot at the end. Okay, so that is the end of the cruise control lesson. As you can see, it took me 20 minutes to do that. And that's with not a lot of experience. So good luck, everybody. I hope this helps.